Hi everyone, so for this video we're going to be looking at how to evaluate integrals using U substitution. So we got two questions here, so let's look at the first one. We're going to find the integral of 3 sine 3x. Okay, so here's the thing. Anytime you want to do these type of integrals, you first need to define what U is, differentiate that, so you find du, and then the whole point is when you do this, you kind of want things to kind of cancel out to make it a little bit easier for you when trying to find the integral. So as a rule of thumb, usually U is like inside part of the function or has something that has a power, something that will help you make it less complicated. So if I look at the first example here, I'm going to say U is just going to be 3x. Okay, so I see that there's this part here. And so if I take the derivative, du, okay, that gives me 3 with respect to x, right? And so, let's see, well, notice in my original problem here, I'm going to be substituting 3x with the u, but I also have this dx here, which is what I also see here. So I'm going to solve this equation in terms of dx. So I'm going to divide by 3. So I have dx is equal to du over 3. And I'm going to move this over so I have some room. We'll do this one on the next one. Alright, so I have this. Let's make sure we know how this is helpful. And what I'm going to do is I'm going to substitute the 3x, but I'm also going to substitute the dx. So if I do that, I have 3 sine of u, because that's what we said our u was. Now dx, when we look over here, is du over 3. Now, like I said, you want to be able to do this so that things kind of cancel out. And so what I've noticed is that these 3's are gone, which makes this very much very easy one, because now it's just the integral of sine of u with respect to u. And if I look, and if you know your integrals, if you don't, look it up. There's that reference sheet there. But the integral of sine is negative cosine. So I've got negative cosine u plus some constant. And then what we're going to do is we're going to go back and plug in what u was. And so u was 3x. So there you go. That is the integral there. Made it much easier when having u substitution. So let's take a look at the second one. Alright, so just like I said before, you want to pick a u so that you can kind of see where things would cancel. So typically you want to find the inside part is usually what I kind of define u to be. So I get u is 5 minus x squared. And if I differentiate that, I get negative 2x dx. Now, just like before, we're going to be substituting u, but we also want to kind of get rid of this dx, so that's everything in terms of u. So I'm going to get dx by itself here. So I have dx is equal to du over negative 2x. Alright, so let's substitute what we know. So we have x still. We're going to, instead of this 5 minus x squared, that's really a u to the 4th, right? And then instead of a dx, we're going to have this. We're going to have du over negative 2x. So again, the nice thing about this is that things cancel. So if they don't cancel, you might want to rethink what your u is. But the x cancels here. And notice this negative 2 is a constant, so I'm just going to pull it out. It's negative a half. But really I'm looking for the integral now of u to the 4th, which is much easier to deal with. So we're going to use the power rule, so it's negative 1/2. And if I multiply that, it's going to be 1/5 u to the 5th plus some constant. So really it's negative 1/10 u to the 5th plus a constant. And just like before, we're going to go back and write down what u was. So really, it's -1/10 times, and u was 5 minus x squared to the 5th plus c. And if you want to kind of combine that into 1, I would just leave it kind of like maybe 1 fraction. And there you go. That is our answer.